and thank you for joining. Let's take a look at some practice questions with reflections of functions. And we are focusing on reflections over the x and the y axis. Now, whenever you practice homework questions, it is very important that you first read the lesson notes that are related to that homework and make a summary of the key information or key points that were taught in class. And once you do that, you will see that you will find completing the homework not only much more easier, but a lot more enjoyable. So, when it comes to reflection over the x-axis, which we also call the reflection of the y-coordinates, we know that the reflection line is the x-axis because that's what it says. Now, the x-coordinates will remain the same, whereas the y-coordinates will go to the opposite side of the x-axis, and they will change the sign to opposite. Let's say imagine a point being here, then this one will go to the other side of the x-axis, so the y-coordinate is going to change, let's say, from 1 to -1. Now, if y equals f of x, then the reflection about the x-axis is indicated by this minus in here in front of f of x. And the reason why is because the y-coordinates, or the f of x, will switch sign to opposite. Now, the invariant points are located on the reflection line, always on the reflection line. And since the reflection line here is the x-axis, then the invariant points will be located on the x-axis. So if you want to find the coordinates of the invariant points, then you have to think they're on the x-axis. What coordinate do I know for sure for a point on the x-axis? So you know that any point on the x-axis has a y-coordinate equal to 0. So to find the coordinates of invariant points, when you reflect a function over the x-axis, you're going to set y equal to 0 and then solve for x. Now, the coordinates of the invariant points then will be in the form x and 0. And we're talking about this x that we find when we solve the equation. Now, we're going to look at the first example. What we have in here is a reflection of function f of x over the x-axis. So we have to find the equation in the most simplified form and also determine the invariant points. So if we're finding reflection about the x-axis, it means that we are building negative f of x. So what that means is that we're going to give a negative, the entire f of x. Now look at f of x here. It's this entire expression. So we're going to keep that in brackets because this entire thing is going to change sign to opposite. And in a more simplified form, we're going to rewrite this as negative 2x squared, then plus 7x, and then plus 4. So this would be negative f of x. Now, in order to determine the invariant points, we will think this is reflection about the x-axis. Invariant points must be on the x-axis, and on the x-axis the y-coordinate will be 0. Therefore, I have to set the y-coordinate equal to 0. Now, it is kind of hard to memorize all these little rules that we have to follow when we find invariant points during function transformations. So it is very important to understand where they come from, because when we understand them, we remember better. So we don't have to store them. We just have to think about them. So one thing that I want you to think of right now is if you want to find the invariant points and you set y equal to 0, now thinking that invariant points belong to both equations, then we must think that it wouldn't matter which equation we use to find the invariant points because there are points that belong to both graphs. However, if you were to choose, you would choose a given function. And the reason why is because when we transform a function, there are possibilities of making errors. So instead of using a function where we could have or maybe not made a mistake, then we choose, and it is best to use the given function. So we're going to make y equal to 0. Should we say f of x equal to 0? It's the same thing. And we're going to write 0 equals 2x squared minus 7x minus 4. And from here, I think we can factor. So this will factor to x minus 4 to x plus 1. from where we get that x equals negative 1/2 or x equals positive 4. So therefore, the invariant points will be at x equals negative 1 over 2 comma 0 or x equals positive 4 comma 0. Now, in the same way, you can try the next equation, and I'm going to move on to the next example 3. So again, we're trying to reflect over the x-axis. When you reflect over the x-axis, it means that we are building the function negative of what we have, g of x. So what that means is that we're going to give a negative sign to this entire g of x in here. So we're going to rewrite this as 1 over x minus 2 and then plus 4. Now I want you to think, is there anything that is missing at this point? So when we reflect the entire function over the x-axis, then we are reflecting the entire expression that is on the right side. So what that means is that we're going to need to set the brackets in here or add the brackets. And in a more simplified form, we're going to rewrite this as negative 1 over x minus 2. And then, so you can give the negative 1 to the numerator, it's easier. Or you can keep it in front of the fraction. And then this negative is going to apply now to the positive 4, so that will make a negative 4. So therefore, we're going to say that the function negative g of x will be negative 1 over x minus 2 and then minus 4. Now we're going to find the invariant points. So for invariant points, and we're going to use an acronym because it's kind of a long word, and math doesn't like very wordy language. So we're going to use symbols IP always for invariant points. So remember that reflection over the x-axis, y would be equal to 0. So we're going to say 0 equals, remember we're using the original function, 1 over x minus 2 and then plus 4. So we'll have to solve this equation. It is a little bit of an unusual equation. We don't solve a lot of these in grade 11, but it's not that difficult, quite logical. So we're going to take number 4 to the other side of the equation, or we can take 1 over x minus 2 to the other side of the equation. So I'm going to take 1 over x minus 2 to the other side, which means that this term here will change to opposite, so to a negative. Oopsie. Wasn't supposed to happen. And then we have on the right side number 4. So as you can see here, we have a fraction, or so to speak. So this is a rational expression and a number. We're going to make them both into fractions. And now we'll cross multiply. Here we go. And we'll have 4 times x minus 2 equals 1 times negative 1. And 4x minus 8 equals negative 1. 4x equals negative 1 plus 8, that will make us 7, so that makes x equal to 7 over 4. So in this case, we found only one invariant point, and this invariant point has x equal to 7 over 4, and we already know that the y-coordinate is 0 because it's a reflection over the x-axis where y is 0. So next we have a square root function. So again, we are reflecting over the x-axis. I'm going to write this down in here because that's something new that I have just learned, so I have to repeat saying this to myself. And that is how it becomes more and more natural for my brain to understand what I read, okay? So reflect over the x-axis, right? Which means that I'm trying to find negative this time we call it k of x. All right, so let's try to find negative k of x. So what that means now is that we're going to give a negative sign to this entire k of x that we have here. So negative, and then we have root of x plus 3 minus 1. Do not forget the brackets around this entire function in here because the entire thing is being reflected in this case. So that will give us negative k of x equal to negative root of x plus 3, and then the negative 1 will turn to positive 1. So this would be negative k of x, or the function, equation of the function kx reflected over the x-axis. Now we're going to do invariant points. So invariant points over the x-axis, it means y equals 0. So we're going to say that 0 equals root of x plus 3 minus 1. Now, remember that we're now going to have to use the original equation, all right? But it is equally, legitimate to use this equation as well. But we'll use the original always. And we're going to solve the equation for x. X is inside the root, which means we need to isolate the root first. So I'll bring negative 1 to the other side to make it positive, and then x plus 3. Now I wanted to think, how can we get rid of the root? Now, to get rid of the square root, we need to bring this to the power of 2. Remember that roots are nothing but exponents in rational form. So a square root is a power of 1 over 2. Now, if you bring the one of the sides of the equation to the power of 2, we got to do the same thing to the other side. And that will give us 1 equal to x plus 3. Now, isolate x, and we get x equal to negative 2. 1 minus 3 is negative 2. Therefore, we're going to see that there is only one invariant point here, and it is located at x equals negative 2 and y equals 0. Now, I am going to quickly show you also how this is going to look like on Desmos, and that's another way for you to check your answers as well at home. So I'm going to draw this very quickly. So I am going to write here the function, we call that kx, so why not keep it the same, is equal to, we had the square root, I think that it was x minus 2, if I remember it correctly. And then outside the root, we had plus 1 or minus 1. I think it was minus 1 because it became positive. Let's double check. Where are we? Here. So, it was x plus 3 minus 1. Let me correct that. X plus 3 minus 1. Okay, cool. Now, next thing that you want to do is write the equation y equals, and then we're going to give it a negative kx. So as you can see here, we have two graphs. The red graph is the given graph, and the blue graph is the, as you can see here on the left side, they're colored in blue and in red, right, as well. And the blue graph is a reflected graph, and as you can see here, one of the points during the reflection didn't change location, and that is exactly where the graphs had their x-intercepts at negative 2 and 0. Now, in the same way, you can check your answers for the other questions, for the quadratic in here, and then for the reciprocal as well. Now, in the next video, I will go over reflections over the y-axis. Thank you for learning with me, and bye for now.